welcome to another session of your course Internet of Things, Design Concepts and Use Cases. In the previous video, we have talked about basic interfacing of LED with your Arduino module with the help of pin number 13. But now we are stepping ahead with other pins as well as a switch connection. So first of all, let me show you a direct connection of LED with Arduino board without using any program. So as a beginner, we know that first we need to connect this particular wire, and next to this we have to make connections of our LED. So here you can see I have inserted my LED as you already know from the previous video. I will be picking up one anode and one cathode terminal from my LED. So you can see as the larger flag is your cathode terminal. So I am connecting this yellow wire to my cathode terminal, and similarly the anode terminal on the other side I am connecting with this blue wire. Now on the Arduino board I am using this yellow wire with a ground terminal. So here I have made connection, and similarly the second wire I am connecting to 5 volt of this Arduino board. So our basic connection is ready. What we are trying to do basically, I am applying direct 5 volt to this LED to check if it works with this direct voltage. So now let me connect this wire with USB terminal, and you can see our LED started glowing directly. At right time, I have not uploaded any program to my Arduino board because I am supplying directly 5 volt to this LED right here. As an enhancement to this, what we can do is we can add a resistor to change brightness level of this LED. So let me just take out this wire so that we can make a additional connection. A very simple terminal connection I have to do with this resistor. So I have picked a 220 ohms resistor. You can see the color coding information of all these resistors in e-content provided with this particular session. So I just removed one of these wires, and within the same vertical terminal I have inserted one leg of my resistor, and I am putting it in another vertical terminal. Now I can use this wire again to insert in the extended terminal. So it will again complete my series connection, and in order to run it again I need to put this wire here, and you can see with a slightly reduced brightness our LED is still working because this is a multicolor LED. So you can see different colors in sequence within this. So this is your resistance based reduction of LED brightness. Now we can extend it a step further with the help of a coding process. So earlier I used a built-in LED terminal that was pin number 13, but it does not mean that you cannot use any other terminals. Instead, we can code each one of them in our software. So let me make an extension with this system. Let us see another program that you can see now on your screen. We have blinking single LED code over here. What I have written in this particular system is, first of all, within your void setup, I am going to use pin mode 10. It means I will be connecting my LED to pin number 10 on this Arduino board, and I am declaring this particular pin as an output pin so that this LED works as an output device over here, and whatever I send from this pin number 10, it will be displayed accordingly, or the behavior of LED we can control through this pin number 10. So this particular code I have explained to you. Next to this we have void loop section that we already know for the repeated task. In this now, first I am using a digital write. Why digital write? Because I am going to use digital port of this Arduino board for making LED connection. Therefore, I need to write the digital information into the specific pin where LED is connected. So, first thing that I am writing is a high. That means I will be transferring direct 5 volt to this LED terminal and I am adding a delay of 5 seconds with respect to this high connection. It means my LED should stay turned on for 5 seconds. Next to this, I am keeping it low for another 5 seconds. So, this is your entire sequence of code. It is your choice how much delay you want to put in both sides. So, that different experiments you can always do with your system. So, let me first show you the hardware part we are going to use as it is, but the pin number anode terminal now I am taking from this 5 volt and I am inserting it within this pin number 10 that you can see 8, 9 and 10 terminal I have used. Now my connection must be ready and we can start transferring our code by inserting this wire. So on your screen, first I need to compile my code. It will take just a few seconds to run and then we can see if our code is free of errors or not. So you can see it says done compiling. Now we are ready to hit the upload button. So let me click on this and you will see our code is compiling, that is a verification step, and after this it will be sent to the Arduino board, making sure your board is accurately connected and COM port is accurately connected over here. So you can say it says done uploading and accordingly now our LED is turning on for 5 seconds and you can see it turns off for again 5 seconds. So this sequence will keep on as long as the same code we have inside this Arduino board. So even if I take this wire off and I connect it after 5 days or 10 days, my LED will start working in the similar manner. So this is how you can control behavior of a LED with the help of this programming. Now we have one step ahead to go. Currently, we are using only one output device with this system. Now, we can use one input device as well. So, here you can see I have two switches in my hand. Both of them are similar type. We are using a push button switch. Either you can use this particular switch with these 4 wires available, or you can use a simple switch module which has these 3 wires directly for connection of your VCC 5 volt, ground as well as signal terminal. So many times beginners get confused about different wires available on this simple push button switch. In this case, either you can check availability of a diagram on your system, such as I have opened one for you. You can see these pins on one side are connected to each other. Similarly, the bottom side pins are also connected to each other, as you can see on your screen. So the connections that we can make, one side of this you can consider as a data output, other side of this you can consider as a ground terminal, and this side you can consider as a VCC terminal. But if you feel still confused for using this tiny switch, it is better to use a module which makes connection pretty easier for beginners. So that is why I have picked up this module for you all. So how we can connect it simply? Let me just first take out this wire so that we can extend our connection, and I will be side by side opening a code for you all that I will explain one by one. First of all, because you can see we have male connectors on this side. So that is why I may need a female connector to establish connection on this end. And on the same time, as I need to make further connections on my breadboard, so other terminal I need with a male connector over here. So similarly, I am just updating my existing connection. You can see the ground terminal I have picked for LED already here, but one more additional ground terminal is already available on Arduino, and you can find one ground at this point as well. So we can use ground any one from both these positions. Similarly, we need a 5-volt connection, which we can extend from this power terminal right now, because 5-volt is currently unused here since we have shifted our LED connection to pin number 10 already. So let me just pick up these wires. First of all, we need to pick this negative terminal, which is a ground. So I am picking up this one, and we can insert it into the ground terminal on the other end. So this is the first connection I have made. Secondly, I can pick my VCC terminal, so which is the middle one. So let me insert my wire in this, and as soon as this connection is ready, we can use this 5-volt on the other side of Arduino. Second connection is also ready, and now we can pick up the signal terminal. So this signal terminal will basically help us read inputs from this particular device, which is going to work as an input device right now. So let me choose a pin 7 from this terminal. So here we have pin number 7, and I have inserted that over here. You are not restricted to use a specific pin from this module. You can choose any one from the port available, but the same pin you have to declare in your code. So let me show how you can do that in the coding part. Here you can see the first thing we are doing is we are defining LED pin. In the previous program, I have used define technique for your LED, but now one more technique I have shown you. You can see here int LED equal to 10. It is going to define pin number 10 of your Arduino board for LED connection, and definitely this one we will be using further as an output terminal. Next we have a button pin terminal, which we are going to use on pin number 7. So similarly, on pin number 7, I have connected my switch signal terminal. After this, I have declared value function over here, in which I will be storing my further information from the input device. So this will be for next use. Next we have void setup, within which first I have declared my LED as an output device, and similarly your button pin as an input device. Now we come to the loop section. Here you can see we have used a if-else sequence. First of all, I am going to read my button pin, which is declared as a digital read pin over here, because I have connected it on my digital port. So I have used digital read on same button pin where this wire is connected, that I have declared in the beginning. Whatever I am going to read from this particular sequence, that will be stored in value. It means when I am going to press this button, the value of this particular button state will be stored in value function. That will be definitely a 0 or 1, since we are reading it with a digital system. Next to this, I have entered a if sequence with value assigned as 0. So with this particular operator, what we are doing is we are checking state of your value variable. So if it is low in the if condition, it means if condition will turn on, and proceeding with this, our LED will be turned high. On the else sequence, we have entered opposite to this. It means in case if this value function is high, the LED will turn low, which is a off state. So this particular sequence of code now we are ready to insert into this particular hardware connection. So first of all, I have to compile this code. So let me hit on the tick mark button on your software, and in the meanwhile I can make this wire USB connection. So I have inserted it here, and in the meanwhile our sketch is also compiling, and you can see our LED is still following the previous behavior since the code in this hardware is not yet updated and it is continuing with the previous code. Now the compilation part is done. I can hit on the upload button and it will just re-verify entire sketch by compiling it, and then within a few seconds it will be uploaded, considering that the port is connected accurately and Arduino board is selected well. So now you can say it is done uploading status on your screen. So we can see the status over here. The LED has permanently turned off now because now we are going to control it with the help of a switch. When I'll press this particular switch, it will turn on. As long as I'll press it, it will stay on. If I release it, the LED will be turning off because the same condition I have added in my software. So in this manner, every time you can control the behavior of your LED, and in same sequence you can add multiple LEDs whose sequence you want to control with different pins. So till now we have done experiments with a switch condition on your LED, and in the coming sessions we will be working with LED bar graph and with different types of input output devices. Till then you can experiment with this particular sequence and you can change your pin numbers in code as well as in the hardware. So keep on practicing and we will meet again in another video with a different set of experiments. Thank you very much.